Okay, if you have any question, please ask me now. Okay, as I will repeat again, the classroom that we will use for our exam tomorrow. Okay, our exam tomorrow at 12:30 p.m. is 9123 and 9124. That's the room number. Okay, those two rooms is actually in front of Kikau building. Sorry, it's in Kikau building in front of FME building, and that particular room is in the second floor. Okay, so it's better for you to come earlier, as you are required to reach class by 12:30 in the afternoon. It's better for you to be there before that. Okay. Jadi ruangannya itu ada di 9123 dan juga 9124 itu di GKU, di depan gedung FTMD, ya, lantai 2. Ya, ini pas di lantai 2. Tolong datang sebelum jam 12.30 di mana kalian sudah harus sampai di ruangan. Seperti itu. Okay, one more thing. You are required to bring your own ID card, 2 ID card that you need to prepare. Your own Indonesian ID card, KTP, and the second one is your student ID card. And then you need to bring your own pen, your own ruler, and your own calculator. Okay, jadi kalian harusnya bawa alat tulis sendiri, ballpoint, penggaris, kalkulator harus ya, kalkulator dedicated, dan juga kartu mahasiswa dan juga KTP. Seperti itu. Is there any question about the exam? So the exam will be offline only. Okay, we are currently talking about the online option for those who are positive COVID, but already recovered but not yet tested negative, and for those who are sick but already recovered as well. Okay, for those of you that currently hospitalized, okay, after you recovered, you can just contact me again for the follow-up exam. Okay, follow-up exam is only allowed for those really sick and need to be hospitalized. Okay. Any question here? No? Anna Maria Phoebe. Hello, Anna Maria.
Yes, sir.
Seems like you contact me yesterday, but I haven't read your message yet.
Yes.
Tested positive or what?
Yeah, I was positive 10 days ago, and yesterday I checked again, but it's still positive.
I see. Okay. For your case, right? Just wait and see. For your case, if there is no online exam, okay, so maybe you will have to attend the follow-up exam, okay. But just prepare for the online exam because there is a possibility that we have a online exam just for those who tested positive COVID. Okay, Anna Maria?
Okay, sir. Thank you, sir.
Okay, I think that's all. Then for the exam, please prepare your best. And for today, the discussion mostly is about the preparation for the exam. I think I will use the time until 8:30 in the morning to discuss about all the exam problem. But it's up to you guys. If there is no question about the problem that I sent it to you guys yesterday via your class leader, and I posted as well online in the EduNext, okay? if you have any problem with that, then we will discuss for it. Okay, let's discuss about it. Okay, I believe most of you already checked this file. So basically, from the last 5 years, I took all of this problem from the last 5 years, and most of the second midterm exam only have 2 problems. The first problem is about machine, and the second problem is about internal force and moment in combination with frame. Okay, so you can expect more or less like that. But if there is also a possibility of 3 problems, but if we have a 3 problem in the exam, most likely it will be frame problem, dedicated frame problem, dedicated machine problem, and dedicated internal force and moment problem. But most likely we only have 2 problems. So if we have 2 problems, most likely it will be dedicated machine problem and combination between internal force and moment and frame. Okay, so it's a frame problem, but you have to find out the internal force in that particular, in one particular beam in frame like that. Okay, this is some example of the frame problem. In the previous, from the previous exam problem, I believe this is the problem from me for last year exam for machine. Okay, and this is one of the problem. Okay, this is I'm not sure, maybe it's 2 or 3 years ago. This one maybe 3 years or 4 years ago. Okay, this as well, this, and this one. Some of the problem that I found it interesting, and maybe we can discuss as well in the class. Okay, and this is some of the internal force and moment in the frame. So combination between internal force and moment, and as well as the frame. Okay, so you have to find out the internal force, internal moment in the frame, in one of the beam in the frame. Okay, you can see this is some of those cases. Okay, this as well, this as well, this. I believe I already, I will not discuss this because I believe yesterday I already discussed about this because I gave it for your homework problem. Okay, this as well. Okay. Any of you have any problem in those problems? Remember, okay, this is your last chance to ask me about those problems and to ask me about something related to our exam. Tomorrow in the exam class, in the exam room, okay, if you ask me, okay, I will not answer because you are on your own at the time. Please let me know if you have any problem here.
So, excuse me, sir, I have a question.
Who's this?
William, sir.
Okay, William. Which problem?
No, it's exactly not a problem. I just want to ask, what if we encounter any statically indeterminate question?
Statically indeterminate? Yeah, just solve it then. So basically, in the frame, especially in the frame, right? In the frame and in the machine problem, if you encounter the statically indeterminate problem, the first thing, as usual, because it's frame and machine, always start with finding the two force member. Because by doing so, you can simplify the case. Okay, William. Then after that, you go for the multi-force member and try to solve each of those multi-force member. Okay, William. And most likely it will add up. It will be the same. The number of the unknowns and the number of the equations that you have, normally it will be the same. Okay, for some of this problem, yes, if you take a look only one of the beam, most likely for some of those cases, the number of equation that you have won't be enough. Okay, but if you combine it with the other beams, most likely it will be enough. Do you get it, William?
So there always have an answer, so there won't be any,
of course.
indeterminate
So
situation.
if you total all the equations and the number of unknowns for frame and machine, most likely it will be the same. Because if not, we will not be able to solve it. Okay, so but some of you may be a bit nervous if you found out that, okay, for example, this is one of the problem, okay, and we are asked here, wait a minute, internal force at point D. Okay, if you know from the beginning, you are asked to find out the internal force at point D. Okay, so it means that we have to concentrate on this member only, right, William?
Yes,
because by concentrating on that, we will be able to solve for internal force at point D. But if we just take a look directly at that particular member, okay, if you have tried it, right? As usual, we will start to analyze the two force member. Do we have two force member here?
Yes, G and E.
G and E, what else? There is one more.
Is it CF and AB?
Huh? C? Sorry, CF.
Oh,
CF is not possible. Why? CF is not two force member because there is a GD.
Oh, it's
GD,
a pin.
right?
Yeah, sorry.
AB is a two force member. You are correct. AB is two force member, but CF is not. Okay. The two differentiate two force member with the others is very simple. As long as the member is only have a pin joint at both ends, it must be two force member, regardless of the shape of the beam. Okay, William, it can be straight, it can be curving, it can be 90 degrees. Okay, William?
Yes, sir.
So we have two force members. So we can simplify the case. Okay, this one, so we can replace AB with force in the direction of AB. We can replace GE with a force in the direction of GE. So here we have GE, F, GE. What else at C? What should we have at C, William?
The reaction forces of F.
At C here, yes?
Oh, at C, CY and CX.
Okay, correct.
CX. And FX and FY on the right side.
Correct, yeah. FX, FY. Something like that. Okay. But if you just take a look at this, right? Point D is found here. The problem with that, before we solving for point D, we have to solve for the external forces. As you can see here, can we solve for this directly?
Not directly, sir.
Nope, not directly, because we have, in this case, we have 5 unknowns, and we only have 3 equations as usual. Okay, We only have 3 equations as usual, 5 unknowns and 3 equations. So 5 unknown and 3 equations, we cannot solve for the unknowns. So in that case, go for the other multi-force member. What are the multi-force member that we can solve here? William.
AB?
AB? No, AB is not multi-force member. But AB is two force member. We agree about that, right?
Oh, you asked about multi-force member.
Multi-force, yeah, multi-force member. Try to take a look something that is close to the force. Which one? Not William.
The force is held by the steel pipe. So
yeah, still this one, right?
Yeah, that one.
You can go for that one. So let's take a look at that. So we have BF. Yeah, I only concentrate on BF. Okay, what forces that we have there?
BX, BY, FX, FY, and the force
BX,
below.
BY. AB is what?
Oh, AB is two force member, so it's
Don't
FAB.
forget about that because it's very important. You are talking about one unknowns and two unknowns there, right?
Yeah. Okay.
So
it's FAB, FX, FY, and the forces downwards.
FX, FY. FY. I think I will change the direction here. FX, FY. Okay, and the 10 kilonewton downwards. So this is it. For this particular free body diagram, can we solve it?
Yes.
Yeah, we can solve it. After we solve that, what happened to the other free body diagram?
We now know the reaction force on the F.
Yes, right. We know this too. Now, the second free body diagram, we only left with 3 unknowns. 1, 2, 3, right? So now it's solvable. It's always like that. Okay, William?
Okay, thank you, sir.
Yep. So as usual, for the machine and frame problem, start with finding the two force member. And then after that, okay, you have to solve, most of the time, you have to solve all or most of the multi-force member. Okay, sometimes you have to solve all of the multi-force member. In this case, you solve all of the multi-force member. The multi-force member, we only have 2, this and this. Okay. So that's always the sequence. So for the frame and machine problem, it's quite simple. Find two force member, replace two force member with the force in the same direction as the member, then find out the multi-force member, solve the multi-force member one by one. Okay, if you cannot solve it one by one, take a look at the number of equation and number of unknowns in total. So you can solve it together, because sometimes this one is quite simple. Why it's quite simple? This particular problem is quite simple. It's because using the first free body diagram here, you can solve for all the unknowns directly using 3 equations that you have in the first free body diagram. Then after that, you can go for the second free body diagram to solve for the rest. Okay, but sometimes in some cases, okay, we cannot do that. We don't have this this flexibility. sometimes we don't have that. Okay. Sometimes in the first free body diagram, you have 4 unknowns, which you cannot solve. In the second free body diagram, you have 4 unknowns as well, which you cannot solve. But when you join both together, you have 6 unknowns and 6 equations, which you can solve. But you have to solve both free body diagram together. Do you get it, William? Hello, William?
Yes, I get it, sir.
Okay, so don't always expect that you have this kind of problem, which you can solve one by one. But sometimes you have to take a look all the free body diagram, list out all the unknowns, list out all the equation, and solve it together like that. Because most likely, if you draw the free body diagram correctly and you solve it correctly, the number of unknowns and the number of equation will match up, and we can solve it. Okay, for this particular problem, is there any question? No? This is the second problem. This one is a car hoist to lift the car. Okay, mechanism to lift the car. There is one member BCD, and there is a actuator AB. Okay, and the one in question is the force at the cylinder AB. Okay, force at cylinder AB. So in this case, Ali Riyadi. Hello, Ali Riyadi.
Hello, sir.
Hello. Ali, what do you think about this? Can you help me to find out the the member which is the first member first, as usual?
Yes, sir, of course.
Which one is the first member?
It is AB, sir.
AB, correct. Yeah, we only have one right here. It's only AB. AB is the first member, so we can replace AB with the force in the direction of AB. Okay. Beside AB, here, what else that we have? We have member AC, which is not the first member, and we have member BCD, which is not the first member as well. So as usual, in that case, you can draw the free body diagram of member BCD, okay, and you can draw the free body diagram of member AC as well. Okay. Here, I think I will take a look at the free body diagram of member AC. This one. Yeah, yes. Okay. Oh yeah, by the way, the attendance, I already opened the attendance, so you can mark your attendance there in academic.itb.ac.ag. Okay. Ali Riyadi, for this particular member, AC, what forces that we have there?
We have CB, sir. BC.
BC? What do you mean by BC?
This is
This one
AB,
is
right,
this.
sir? Oh.
That one.
Oh, we have the car.
The
car, the weight of the car.
The weight of the car, correct. 6 kilonewton here. What else?
OA.
O. Yeah,
OA.
at O. OA.
Yes.
What do you mean by OA? O. At O here, there is a hinge.
Oh.
So it's supposed to be OX and OI.
Oh, yes.
Yes. At A, what do you have at A and what do you have at C?
Also a pin, sir.
Yeah, at T is a pin, at O is at A is pin, at C is a pin. But remember, at A there is a two force member, right?
Yes, it's
So at
FAC.
A,
FAC.
AC or AB?
AB.
AB. Okay. So we have a two force member. This one is FAB, and then at C here, yeah, CX and CY. Okay. How many unknowns that we have here?
5.
5, right? Yeah, we have 5, and we have 5 unknowns, and we have only 3 equations. Okay, but now let's try to take a look at the other free body diagram. Okay, this one is not solvable directly, but now let's take a look at the member BCD. Okay, we have at C, at B, and here. Okay, at B there, what forces that we have?
DY, sir.
Huh? BY?
DY
at
D.
B. Yeah.
Oh, BB, FAB.
FAB, correct. This one, FAB. What else? At C?
At C, CYCX.
CYCX. Supposed to be the opposite of what you draw in the previous one, because it's action and reaction, okay?
Yes, sir.
And then at D, it's a roller.
DY, sir.
DY. Okay, now let's take a look at this. How many unknowns here in the second free body diagram?
4, sir.
4 unknowns, 3 equations. Cannot be solved as well. But now I want you to check the whole system. So both of the free body diagram, this and this, how many unknowns in total?
9, sir.
9, are you sure? Let's take a look.
Oh,
Don't just add up like that.
yes,
5
yes.
plus 4 now. Take a look. OI, OX, 1, 2, right? FAB, 3, CX, CY,
6, sir.
5,
6.
5, right? CX, CY here is repetition, FAB
Yes.
is a repetition, and TY, 6, right? So in total, we have 6 unknowns. How many equations that we have in total?
6 as well.
6 as well. It's supposed to be solvable, right? Ali Riyadi, yeah?
Yes, sir.
It's supposed to be solvable, but in order to solve this, yeah, you have to combine the equation in the first free body diagram and the equation in the second free body diagram to solve it. Okay, William, did you get it, William?
Yes, I understand.
It looks like it's a statically indeterminate case, but if we take a look in total, the number of equations, it will be the same with the number of unknowns. Okay. So for this one, it's just a mathematics. You just have a 6 equation. You have you have a 6 unknowns as well. Okay. For this problem, I believe I already gave it to you guys in the homework. So if you still don't understand on how to solve this, please take a look at the video of this the video discussion on this particular homework. Okay. For this particular case, we are asked to find the gripping force is 200 Newton, this one, and we are asked to find the force Q. Okay, the force Q which is applied to the circular circular branch. Anyone here having a problem with this? Because I believe I already give you although it's not exactly the same as this particular problem, but in the homework before, I already give a quite similar problem to this. So I believe it will be okay for you to solve it. Although for this one, the geometry will be quite, it's slightly difficult to solve the geometry. Okay. And this is another problem, leaf for the truck. Okay, wait a minute. Okay, a lift for the truck. And I'm so sorry about the Bahasa. The problem is still in Bahasa. Why? Because this one is 5 years ago, 5 or 6 years ago, when class international is not there yet. International class is not there yet. Okay, so we are talking about the lift here. And the one in question is this one, the hydraulic force there. Okay, the one in question is hydraulic force here. Okay, let me discuss it together. What's this? Davi Rizky. Halo Davi. Hello, Davi. Davi is not there. In that case, Audrey Vanita. Hello, Audrey.
Yes, sir.
Okay. For this particular case, right, Audrey, as usual, because this one is machine problem, hominin A, can you determine which one of the member is a two-force member?
Is it DE, sir?
Yes, correct. D is two-force member. Okay. D is two-force member, so we can simplify DE. Okay. And then let's draw the other multi-force member. The other, like FCB and ACD, are two-force member, right? As well as this one, the top box right there is a two-force member, right?
Oh, yeah.
Okay, now let's take a look at those. I first want to take a look at FCB. FCB there. Okay, what forces that we have at FCB? F, C, and B. There is a roller here.
There's FX and FY.
Yep. Y. FX, what else?
And then CX and CY.
X, CY. Sorry. CY, CX. What else?
And BY.
BY. Okay, so we have 5 unknowns, 3 equations. We cannot solve it, right? And now let's take a look at ACD. Roughly like this, with this. What do you have there?
There's AX and AY.
Hmm. What
And
else?
CX and CY, but the other way.
Opposite. Yep. Yes. CXY. And
And
roller there. Right? So it's supposed to be dy, right?
Oh yeah.
dy, but remember there is a dE there. So there must be FDE there. In this case, we have 6 unknowns and 3 equations. Okay, we cannot solve it as well. The last one, the top box, and the top, the part where we put the boxes there. Okay, there is B here, A here. Okay, at G1 60 kilogram, at G2 85 kilogram. So what forces that we have here in this part?
There's AX and AY.
AX, AY, so it's supposed to be the opposite. This one is AY, AX. I think this one, I will just replace the direction. Okay, what else?
And then there's BY.
Y. What else?
And then the G2 and G1.
G2 and G1. Okay, this one and this one. G1 is G1 85 kilogram, G2, G1 60 kilogram. So using 10, 600 Newton, right?
Yes.
And this one is 850 Newton. Okay. For this particular problem, we have 3 unknowns and 3 equations, right?
Yes.
Okay, can we solve this one?
Yes.
Yeah, we can solve that one. So we start with the one that we can solve. In that case, we found out AX, AY, and BY. Okay, so these 3 are solved. Okay, now we left with 4 unknowns. In this case, we left with 4 unknowns as well, right?
Yes, sir.
Okay, but now from this to free body diagram, how many unknowns left in total that we have?
1, 2, 3, 4, 6. 1, 2, 3.
We have CXCY is not yet solved. FX, FY is not yet solved. DY is not yet solved. FD is not yet solved. So in total, we have 6, right?
Yes.
6 equations as well in total, right?
Yeah.
Using 3 from this, 3 from this, so we can solve it together. But of course, you have to join both equation from both free body diagram. Do you get it, Audrey?
Yeah, I think so, sir.
The equation, the calculation will be tedious, but it's solvable. Okay, the calculation will be long, but it's solvable.
Okay, sir.
Good. Okay, so that's the way to solve this one. Try to take a look which part of it is a 2 force member. Replace the 2 force member with a force in the same direction as the 2 force member. Then just disassembly all the multi-force member, and after that you can try to solve for the multi-force member one by one. Okay, you can solve for the multi-force member one by one. Sometimes it's even possible for you to solve for the whole free body diagram. The whole free body diagram to find out for the external forces. But sometimes it's not necessary to do so. just disassembling everything and solving the multi-force member free body diagram one by one is supposed to be enough. This is interesting case as well. Okay, this one is about fork. Yeah. To be honest with you guys, right? This is one of the problem that I prepare for the exam yet tomorrow. Okay, but unfortunately, it's already been discussed in the other class. So that's why I will discuss it with you guys, because there is no use of using this problem anymore in the exam. So we will not use this problem in the exam, but we can discuss it in class. Okay. Now, let's see. Muhammad Riki. Hello, Muhammad Riki. Hello, Muhammad Riki. Are you there? No? Why you are not there? Jeffrey. Hello, Jeffrey. Are you there, Jeffrey? Hello, Jeffrey. Not there as well. Safran. Hello, Safran.
Yes, sir.
Okay, Safran. How many two force member that we have in this particular problem?
One, two.
Two, right? We have
Yeah.
two. What are those?
A, B, and DF.
Yeah, A, B, and B, DF are two force member. So in this case, we can replace both with force in the same direction as the member. Okay. Now we left with only two multi-force member, right? The first one is BC. Okay, I think I will draw it here. BC with the fork as well. Okay, roughly like this. Okay, this is member BC with the fork. Can you tell me the forces which is happening to this? Safran.
On the point B, there is force FAB.
FAB, correct. What else at C?
At C, CY and CX.
Yes, CY, CX. And at and we have W as well, right? 8 kilonewton.
Yes.
In this case, how many unknowns do we have?
3.
3 unknowns. You are lucky. 3 unknowns. 3 equation. Can we solve this?
Yes.
Yeah, we can solve it. So we can solve for this, this, and this. Okay. But the one in question is a reaction force at pin E, right? So we have to solve for CDE as well. If we take a look at CDE, it's like a triangle like this. At C, at D, and at E. At C there, what do you have at C?
CX and CY.
CX, CY, right? But it's supposed to be the opposite, okay? What else?
The force FDF at D.
FDF. And then?
And
E?
then CX, EX and EY.
Yeah, EX. Sorry, EY, X. Okay. How many unknowns that we have here?
5.
5. But we already solved for this, right?
Yes.
Yeah, so we left with 3 unknowns and 3 equations. Can we solve this?
Yes.
Yeah, we can. So this one is as simple as that. As long as you solve for this one first, solve for the BC and the fork first. Okay. So actually, frame and machine problem is mostly like that. Okay. It's either you can solve the unknowns one by one. So try to find the multi-force member free body diagram that has only 3 unknowns. Solve it first, and then go to the other, which you can solve it as well after that. Okay, sometimes that's the case. It's easy case, but sometimes there is a difficult case where you have to combine the equation from one free body diagram with the equation of the other free body diagram to solve for the problem, like this one. And this one as well. Okay, but it's not supposed to be a big problem because it's still solvable. Okay, now I will go with the review of the second part. If you have a frame problem, but you are asked to find the internal force and moment at the frame, internal force and moment diagram at the frame. This is some of the case here. In this case, you are asked to find out the you need to draw the diagram, internal force diagram of member A, B, C, D. Okay, this one. And there is a distributed force there. Okay, but as usual, because this one is a frame problem, we always start with finding the two force member. Okay, we start with finding the two force member. Okay, Adam. Hello, Adam. Hello, Adam. Adam is not there. Why there are so many of you that is not there? Sleep again or what? Davi Rizky. Hello, Davi. Are you there already?
Hello.
Hello, Davi. Okay. Would you mind to show me the two force member in this particular problem?
There is none, sir.
None? No, there is. CH is a two force member. CH is two force member, although the shape is L like that. Because as you can see there, right? CH, it's only have a it has a pin at one end and pin at the other end. So if that's the case and there is no friction there, it must be two force member. Okay, David?
Yeah, okay, sir.
So this one is two force member. So we can replace this with a force in the direction of CH. Now, the direction is like this. From one end to the other end. That's the direction of the force. Okay. But we are asked to find out the distribution of, not the distribution, the diagram of the internal force of A, B, C, D. Okay. In that case, we have to know what is happening at A, what is happening at C, and what is happening at D as well. Okay. So we have to solve for the external forces first. We have to solve for those forces first. How to do so? Then we can solve it one by one. Okay, we can solve it one by one. If we take a look at the member A, B, C, D, right? what we have is like this. Okay, there is a distributed force. (500 Newton per meter). And there is a pin FE there. Sorry, there was force at A, C, D. Okay. At A there, what forces that we have at A? David?
X and AY.
X, A, Y, right? Then at C, remember CH is 2 force member.
FCH.
FCH. Then at D, it's a pin. So at D is what?
DX, DY.
Okay, dy, dx. How many unknowns that we have here, Davi?
5.
5 unknowns. And oh, we have a force here. P is what? 1000 Newton. So here is supposed to be 1000 Newton. I forgot. We have 5 unknowns. 3 equations. So we cannot solve this. Okay, we have to go for the next free body diagram to help us to solve for this. Okay. Let's take a look at this. Remember this one. GDF. Okay. GDF. Okay. At G there, what forces that we have?
GX.
GX only, correct? And at D,
DX.
it was DX, dy, right? But the opposite of the one that we drew before. Although most likely the direction is wrong, so I will just revise this. Okay. Then at F.
FX and FY.
FX, FY. The problem now, we have 5 unknowns and 3 equations only here. Okay. But if we take a look at the pulley, we're supposed to get the Fx and Fy, right, Davi?
Yes.
Now we take a look at the pulley first. This is the pulley, and we will have a Fy, Fx here. Okay. And what else that we have here in the pulley?
The radius.
Radius, yeah, radius 0.5 meters. And what else? How about the tension force?
The tension is same as P.
Sorry? Sorry, David. I can hear you. The tension?
1 kilonewton.
1 kilonewton, yeah. But which way it's going? And where we're supposed to put it?
To the left.
Yeah, to the load. Okay, 1 kilonewton. What else? There is another more, and there is another tension there.
To the E.
Yeah, this one, right? 1 kilonewton. Okay, we can solve this first. We have 2 equations, 2 unknowns, sigma Fx and sigma. Sorry, we can solve this using sigma Fx and sigma Fy equal to 0, sigma moment equal to 0. Sigma moment equal to 0, we got this. Sigma Fx equal to 0, we get this. And sigma Fy equal to 0, we get this. So Fx will be equal to 1 kilonewton. Fy will be equal to 1 kilonewton. Okay. Now, if we take a look at that, how many unknowns that we have here?
3.
3. We have 3 unknowns. We have 3 equations. So we can solve this. Okay, dx, dy, gx will be solved. In that case, we can go for the first free body diagram. Dx, dy are solved, right? From the previous free body diagram. Now, if we take a look at this, how many unknowns left here?
3.
3 unknowns. So we can solve this as well. Okay, so we can solve this, this, and this. After solving that, then you can try to draw the free body diagram of, you can try to draw the free body diagram. You can try to draw the diagram, the internal force and internal moment diagram of A, B, C. Okay. Wait a minute. Let me check. Okay, A, B, C, D. So it can be solved right now. And now, to draw for the diagram, how many cuts that we need here? Hello, David?
3 cuts.
3 cuts. Okay, correct. We have 3 cuts. This is the first one. This is the second one. And this is the third one. Okay, if we take a look at the first one, so if we take a look at the first cut, okay, it will be like that. There will be a distributed force, 500 Newton per meter. Okay, we have AX, AY, but you know the value already. The internal force and moment that we have there is like what, David?
V and M.
Sorry?
V, M, and N.
Oh, phi, yeah. Phi is going which way?
Down.
Down. Normal force is going which way?
Opposite of AX.
Opposite of X, not necessarily. We have to put the positive sign, right?
Yes.
Yeah. Phi here is going down because if the positive sign is like that. Normal force, the positive is like this, always tension. Okay, how about moment? Moment, the positive is going which way?
Counterclockwise.
Counterclockwise, in this case. So we can solve for phi and NN here. Okay. Now for the second free body diagram, this is what we will draw. Okay, the vertical part will still be there because we didn't convert it into the to the main beam, so it will still be there. So you have to calculate it as well. AX, AY. Okay. In this case, what internal force and moment that we have?
Still the same.
Still the same. V and M. Okay. Now the last one, the third cut. The third cut is easier for us to just use from the right. Here, don't forget this one is X. This one is X as well. Okay. We cut from the right. We have dx, dy, and what internal forces and moment that we have there? V and M, right? Phi positive is supposed to be going which way?
The opposite of the other side.
No, not the opposite of that. Always you have the positive, right? It's clockwise, right? So it's going up, but the reason is because it's clockwise, right? Davi?
Yes, sir.
The positive direction is clockwise, and normal force, the positive direction is what?
To the right.
To the left because tension.
Ah.
Yeah, to the left because tension. And moment, the positive direction is supposed to be
Clockwise.
clockwise because it's always making the beam smile. Okay, and in this case, the distance here is supposed to be what?
X.
X, are you sure X? X is from the left. We cut it here, right? Roughly we cut it here. So this one is X. This one is what?
6 minus X.
6 minus X, correct. 6. Okay. Like that, okay, David? So you can solve for V and NM here, V and NM here, V and NM here. Okay, David?
Okay.
Okay, this is some other example that we have. I think I will discuss about this first. Wait a minute. Neila, hello Neila. Neila, are you there, Neila? Neila Fatia? Why your voice is very... the volume is very small. Hello, Neila?
Hello, sir.
Now it's better. Okay, as usual, we start with to solve for this problem. This problem is you are asked to find out the distribution here, PEFG. Okay, but because it's frame problem, we always start with determining the two force member. Do we have a two force member here? Hello, Neila? Hello, Neila?
Hello, sir.
Do you have a two force member here?
Sir, I'm sorry, but you're kind of breaking up your voice.
My voice is breaking up. Is it still breaking up? Hello, is it still breaking up?
To me, yes, sir.
Okay, I'm not sure, but Alberto, hello, Alberto. Is my voice breaking up, Alberto?
No, sir. It's okay.
Okay. In that case, your connection seems the problem. Okay, then. Because Neila have a connection problem, I think I will point out to somebody else. Asal Herlambang. Halo Asal.
Halo Pak.
Di sini ada gaya apa? Ada batang dua gayanya tidak?
Ada Pak.
Apa itu? Yang mana?
AB sama FD.
Oke, AB itu sebenarnya bukan batang dua gaya, tetapi dia tali ya. Cuman arah gayanya betul sesuai dengan arah talinya ya. Selalu tarik ya di sini. Dan juga DF ya.
Iya.
Oke, kalau DF arah gayanya, kalau DF ini arah gayanya sesuai dengan arah dari ujung ke ujung seperti ini ya. Oke. Yang ditanyakan adalah BEFG. Kita coba lihat langsung BEFG apakah mencukupi atau tidak itu ya. Kalau BEFG seperti ini G, ini F, ini E, ini B. Gaya apa saja yang ada di sana? Gaya apa saja yang ada di sana?
B,
Ya, yang di B itu apa?
gaya tension.
Tension, ini ya. FAB. Terus habis itu DE ada apa itu?
EX, EY,
EY dan EX. DF,
FD,
FDF ya. Oke. Di G
ada weight,
weight-nya 100 kg pakai 10, 1000 ya. Oke. Berapa anons ya di sana?
4.
4 ya. 4 anons, 3 equation. Kita nggak bisa selesaikan. Nah, multi-force member yang lain yang mana ya? Bisa kita coba selesaikan untuk membantu.
CDE, Pak.
CDE, betul. Kita lihat CDE. Ini C, ini D, ini E. Oke. Di E ada apa?
EX, EY.
Balikannya tapi ya.
Ya.
Oke, terus di D ada apa?
FDF.
FDF. Karena tadi tekan ya, diasumsikan tekan di sini juga terpaksa tekan ya.
Ya.
Oke, di C?
CX, CY.
Berapa anons?
5.
3 persamaan ya. Oke. Nah, kalau kita lihat secara total, dari 2 free body diagram di sini, free body diagram pertama dan kedua, secara total ada berapa anons?
Pak.
6 anons. Secara total ada berapa persamaan?
6.
6 juga. Kita bisa selesaikan ya. Tetapi kita selesaikannya dengan cara menggabungkan persamaan yang ada di free body diagram pertama dengan persamaan yang ada di free body diagram yang kedua. Gitu ya?
Iya.
Oke. Nah, kemudian kita diminta untuk mencari normal force, shear force, dan bending moment diagram. Berapa potong yang kita harus lakukan di situ setelah FAB, EX, EY, FDF dapat semua?
3, Pak.
3 ya. 3 potongan. Ini berarti di sini ya, ini potongan pertama, kedua, ketiga. Oke, di potongan pertama kalau kita gambar, ini ada distributed force 3000 ya, Newton per meter, ada FAB. Lalu di gaya dalam dan momen dalamnya apa aja itu?
Shear force ke bawah.
Wah. Terus ada normal force nggak?
Ada, Pak.
Ada. Ke kanan atau ke kiri?
Ke kanan.
Kanan. Tarik ya. Lalu momen?
Counter clockwise, Pak.
Counter clockwise supaya tersenyum. Oke. Ini potongan pertama. Potongan kedua. Oke, potongan kedua itu kalau misalkan kalian tidak mau berhubungan dengan distributed force-nya, itu mungkin bisa langsung ngambil dari kanan, tetapi sebenarnya ngambil dari kiri juga tidak ada masalah. Kita ambil dari kiri aja kayak biasa. Ini ada FAB 3000. Newton per meter. Terus ada EY, EX. Nah, di sini sama persis ya?
Iya, Pak.
Gaya dalamnya V. N, dan M. Nah, kalau potongan terakhir lebih gampang ambil dari kanan. Apa aja itu?
Shear force sama momen aja, Pak.
Shear force sama momen aja, karena normalnya nggak ada ya. Normalnya kita 0, ini 0 di sini ya. Cuman shear force-nya positif arah kemana nih?
Ke atas.
Oke, normal force-nya tetap saya gambar aja ya. Cuman nanti nilainya akan 0. Momennya positif arah ke?
Clockwise, Pak.
Clockwise. Supaya tersenyum seperti itu. Ini kita bisa selesaikan. Kita gambar diagram ya. Internal normal force, shear force, and bending moment diagramnya. Seperti itu. Oke, makasih. Ini kasus-kasus lainnya. Mungkin agak sedikit lebih complicated, tetapi bisa kalian gunakan untuk latihan. Oke? Yeah. So basically, for your second midterm exam tomorrow, okay, most likely the problem is frame and machine. One of the problem is frame and machine. The other problem is combination between frame and machine. Combination between frame and internal force. Okay, but later for your final exam, okay, the things that will be covered here is everything. Okay, the things that will be covered here is everything, and most likely internal force will be discussed as well in the final exam. There will be normally there is a problem about internal force as well in the final exam. Besides that, we will cover new topics about friction in the final exam. Okay. You need to learn about how to handle the distributed force as well in the internal force and moment diagram. Okay, because it will be slightly more complicated if there is a distributed force. Okay. Before I wrap up the class, is there any question regarding the exam? Or everything is clear? Don't forget as well, if we have a pulley like this, okay, we have to solve for the pulley, the force due to the pulley first. Okay, for example like this, we have to solve the pulley B, for example, pulley E, okay, and pulley D. Okay, at pulley D there is a force F downwards, which is 1000 Newton, and then there will be dy, dx, and there will be tension here, T1. Okay, using sigma fx, sigma fy, and sigma moment. Using sigma moment at t equal to 0, we will get T1 is equal to 1000 Newton. Then dx using sigma fx equal to 0, we will get dx equal to 1000 Newton. dy using sigma fy, we will get dy is equal to 1000 Newton. Like that. Okay. Then the tension here is the same. We have tension 2. And then we have dx and ey. Dx, same, using sigma fx, sigma moment at E, we get T2, sigma moment, sigma fx equal to 0, we get ex, sigma fy equal to 0, we get ey. Okay. Everything I believe is it will be 1000. So here is T2, we have T3 here, and then we have Py, we have Px. Same, using sigma moment at T, T3 we get it, 1000. Sigma fx equal to 0, we get Px equal to 1000. Sigma fy equal to 0, we get Py 1000. Now, after we get all the reaction forces at the pin, Px, Py, Ax, Ey, Dx, Dy, we can move the force to the frame. Okay, we can move to the force to the frame. Okay, if we take a look at member ACD, right? There will be a force due to the due to dxt1 there. Okay, the force due to dxdy there. So we can move it there. Okay, then at E there will be exy, we will put it there. At B there will be bxpy, we will put it there. Okay, but don't forget you have to solve for this one first before solving for GED and ACD. GC here is two force member. Beside that, multi-force member. Okay. Before I wrap up the class, is there any question?
Sir, I'd like to ask about the exam tomorrow.
Yeah.
Will there be any rules for rounding up numbers?
Sorry, rounding up what? Who's this?
Oh, Rafi, sir.
Rafi, yeah.
I'd like to ask, will there be any rules for significant figures?
Significant figures, I think it's better for you to get at least 3 decimal points, 3 behind decimal. Okay, 3 decimal number. So the calculation won't be that off from the calculator. Okay.
Okay, sir. Thank you, sir.
Izin bertanya, Pak.
Yap, silakan Hilmi.
Berarti ini untuk yang DXD-nya kalau kita tinjau GED sama ACD itu beda atau?
DXDY di sini itu ada 2 macam berarti ya. Ini DXDY dari puli ya. DXDY dari puli itu mungkin kamu bisa letakkan di salah satu ya. DXDY mungkin kita namakan DXDY puli di sini ya. Oke. DXDY dari puli. Mungkin kamu bisa tinjau DXDY puli itu diletakkan di ACD seperti itu ya. Kemudian dari ACD juga itu ada DXDY ke si siapa namanya? Si GED. Jadi gini, DXDY itu anggapannya itu kayak gaya luar. Kebayang nggak? Ilmi. Jadi di sistemnya kita lihat DXDY itu sebagai gaya luar. Di GED, di keseluruhan sistem yang pulinya sudah dihilangkan ya, DXDY itu kita anggap sebagai gaya luar. Nah, gaya luar itu seperti kemarin, kalau misalkan ada gaya luar di pin, ya, itu kita bisa letakkan di free body diagram yang mana saja. Bisa kita letakkan di free body diagram yang ACD, bisa kita letakkan di free body diagram yang GED. GED ya, ACD atau GED. Nah, kalau saya prefernya biasanya saya letakkan di yang tidak mempengaruhi BIM akhirnya. Jadi saya letakkan di ACD. ACD saya letakkan di XD dari puli. Oke. Setelah ACD saya letakkan di XD dari puli sebagai gaya luar, itu nanti di D juga itu kan ada pin antara GED dan ACD, betul nggak, Hilmi? Betul ya? Nah, itu di pin tersebut itu akan ada muncul di XDY lagi antara ACD dan GED. Nah, kalau misalkan ini ya, misal kelihatannya agak susah kalau saya. Mana teh? Nah, ini. Misalkan ya, saya buat ini ACD. Terus di sini A itu di fix, berarti ada AX, AY, momen ya. Kemudian di B itu ada BX, BY, masing-masing 1000 sebagai gaya luar, BY-nya ke atas, 1000 Newton, BX-nya ke kiri, 1000. Terus habis itu di C ada gaya GC ya, FCG. FCG. Terus di D itu ada dua gaya tadi ya, ada di XDY ke kiri dan ke bawah 1000-1000. Saya anggap sebagai gaya luar. Oke, dan juga saya berikan DY, DX yang merupakan aksi reaksi antara batang ACD dan batang GD. Kebayang ya Hilmi?
Ya,
Nah, nanti di batang GED, kalau kita melihat ke batang GED, itu nanti sisanya tinggal ada DY ke bawah yang dari sini ya, dan juga DX ke kiri yang dari sini. 1000-nya saya pindahkannya kan ke ACD semua kan ya, betul ya? 1000 ke kiri sama 1000 ke bawah saya pindahkan ke ACD semua. Jadi nanti DXDY yang ada di sini itu sudah meliputi itu juga. Terus kemudian di titik E itu ada 1000-1000 juga ke arah kanan, dan ini ada 1000 Newton ke arah kanan dan ke arah bawah. Terus habis itu di G itu ada FCG. Gitu ya. Jadi DXDY yang ada di sini itu adalah DXDY aksi reaksi dengan yang batang yang ada di sini. Paham ya? Seperti itu. Kita bisa selesaikan yang ini dulu, dapat DXDY. Oke, kita dapat selesaikan yang ini dulu, dapat DXDY. Terus kalau mau selesaikan ada pertanyaan yang terkait dengan yang lain, ini dapat, sisanya 3 anons. Sisanya 4 anons ya, di sini 1. Enggak, ini 3 anons, ini udah ketahuan juga, sorry. Berarti sisanya 3 anons, A, Y, M, AX. Bisa selesaikan juga. Oke. Tapi kebayang ya kamu ya, caranya gimana? Halo Hilmi?
Kebayang, Pak.
Sip. Jadi intinya dianggap sebagai gaya luar, ditaruh di salah satu beam, terserah di mana. Nanti di XDY yang aksi reaksi antara dua beam tersebut itu sudah meliputi 1000 Newton itu. Okay, I think that's all for today. All the best for your exam. Okay, tomorrow. Don't forget you have to come to the class. You have to reach the class before 12:30 p.m. before 12:30 in the afternoon. It's better for you to come at 12 at noon. Okay, stand by there and just prepare yourself there. Okay, don't forget to bring your pen, tip X. What else? Calculator. Okay, and your ID card. Indonesian ID card and student ID card. Okay, I think that's for today. If there is no more question, then that's all for me. I can wrap up the class and see you guys in the exam tomorrow. Okay, bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yes, sir.
Yeah, bye.